Hello and welcome all once again in my next YouTube session. Okay, so in the next session we are going to learn about the transistor and a sensor interfacing. So we are going to learn in this YouTube session how can we interface a different sensor for a transistor as a switch. Okay, so there are different sensors like how can we interface a sound sensor or a touch switch sensor, ultrasonic sensor, motion sensor, IR sensor, LDR sensor with respect to the transistor. So how we can control the transistor as a switch using a sensor interfaces. Upon the completion of this YouTube video or a series of this YouTube video, you can be able to build your own small projects at home like burglar alarm or automatic light on and off sensor, sound sensor, etc. etc. But before going for actual practical oriented video, we should aware of the working of a transistor. So in this YouTube video we are going to learn about how the transistor works, what are the different modes in the transistor, and how we can control the transistor. Okay, so okay friend, now let us learn about some theoretical part of the transistor. Now we know basically there are two types transistor. One is called as NPN and PNP transistor. Now in the figure you can observe that in the figure 1 and figure 2. So in the figure 1 we can observe that I have taken the output from the collector side, and in the figure 2 you can observe that I have taken the output from the emitter side. Okay, now basically this transistor is what? NPN. So in the NPN, when the base logic is 1, that is maybe equals to 5 volt, then the transistor is on. And if the base logic is 0, which is equals to ground, then the transistor is off. Now let us see the condition. If we are going to take the output from the collector side, suppose the base of the transistor is 0, that is at the ground potential. So what will happen? The flow of current from the collector to emitter is not possible as the transistor is off. So the maximum the current is going to flow from the collector to the output, and the transistor will be on. Now if we take a same condition, now the output we have taken with respect to the emitter and ground. Now if I apply a base as a 0 potential, that is a ground potential, so whatever the current which is going to flow, it is going to flow from collector to emitter, but as the transistor is off, what will happen? There is a no flow of charge from emitter current, hence there will be the no current at the output of the emitter. So in this case the output is off. Now you can observe that both are NPN, but the way we have taken the output, one is from the collector and another is for the emitter. So if the base is logic 0 and if the output is with respect to the collector, it will on, and if the base is at the logic 0 and output is with respect to the emitter, the output is off. Now we'll change the state of the transistor. Now I'll make a base at a logic 1, that is assume as a 5 volt logic 1. What will happen in the first condition where the output is with respect to the collector? There will be the flow of charge from collector to the emitter. So there will be the less current will be flowing through the collector to LED, but it will directly flow from what? Collector to emitter. So in this case the output is now going to remain off. Now in the second figure, if I make a base as a logic 1, that is as a voltage 5, if I apply, whatever the current charge is going to flow from collector to emitter, and from emitter we have taken the output, hence the LED will remain on. All of you getting this? So it is observed that when the base logic is 1, when we are taking the output from across the collector, the output will remain off, and when the base logic is 1 and we are taking the output from the emitter, the output is on. Now let us summarize this with respect to truth table. Okay, now when the base logic is 0 and if you are taking the output with respect to the collector, so the collector at the output you will get at the collector, that is, so you will get on, so the output is on, and with respect to emitter the output is off. If the base logic is 1, that is equals to 5 volt, then the output as we are taking across the collector, so it will remain off, the output is off, and with respect to the emitter the output is on. So this is as simple as that. So this is with respect to what? NPN transistor. Now let us learn about a PNP transistor. So earlier we learned about NPN transistor. Now let us learn about the PNP transistor. Okay. Now how it works? So in this, the figure 1 and another is the figure 2. So in the figure 1 we can observe that I have taken a similar output at the collector, and in the figure 2 I have taken the output from the emitter. Now this is NPN. So when the NPN transistor is on, when the base is at logic 0, that is at the ground potential, then the transistor is on, then the transistor is on. And if the base is at logic 1, then the transistor is in the off condition. Okay, so this is the logic for PNP transistor, because at the center you can see N. So from the arrow it indicates that whether it is NPN or PNP transistor. Now see, let us see when the base logic is 0. So when the base logic is 0, the transistor is on. So there will be the flow of charge from collector to emitter. So hence at the collector the current will be 0 because it is going to flow from collector to emitter. So when the base logic is 0, at the collector you won't get any output, so the output will be off. Okay, so output will be off. Now in the figure 2, if you apply the base logic as a 0, there will be again the flow of charge from collector to emitter, and so you will get the output across the emitter as there is a transistor on, so it will be remain on. So in the PNP transistor, when the base logic is 0 and if you are taking the output across the collector, it will be off, and if you are taking the output across the emitter, it will be on. Now let us change the logic. If we make a logic 1 over here at the base, so when the logic 1 is at the base, as it is a PNP transistor, as the base logic is 1, transistor is off, so there will be no flow of charge from collector to emitter. So whatever the charge is there, it will flow from collector to the output, that will be towards the LED which is acting as a load. So when it is a logic 1 and if the output you are taking across the collector side, it will on, so you will get the output. And if the base logic is 1, as the transistor is in the off state, there will be no flow of charge from collector to emitter, so hence at the emitter across there will be no output, so it will remain off. So these are a basic fundamental when you should be aware when you are working with the transistor as a switch. So my dear friends, in next upcoming videos we are going to see how we can implement it practically with respect to the breadboard. Okay, thank you. For a next upcoming video, so this will be the series of 8 to 10 videos continuously, and for more updates please like, share and subscribe.